So I'm going to go over polar graphing, and this video is really more as a quick just refresher for students in Calc BC. And if you're trying to learn polars for the first time, I would recommend watching a more robust video. But for polars, all polars are is just a different coordinate system, right? When you have your Cartesian coordinate system, you plot points, and that's just our rectangular coordinate system. You plot points according to an x coordinate and a y coordinate. And with polars, you plot points according to r, which is a distance, like a distance from your pole, right? So as r gets bigger, you're going to be plotting a point farther away from the pole. And you also, so that's one coordinate, like your r, I guess, not really a coordinate, but r is one kind of value, and then theta, so r is kind of like your output. Your theta is your input, and that tells you from what angle you're plotting, right? So if you're plotting at theta equals 0, you plot there. At theta equals pi over 3, right around 60 degrees, right? So to kind of see this in action, let's just start with the most basic example, r equals sine theta. And one way, just to think about polars is like, okay, let's say I have a little, like if I graph y equals sine x, I would get something like this, right? Over here, where this is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. And you can just kind of transform this over to polars, right? By kind of thinking about, okay, well, x is our input, which is really just our theta, right? Because theta is the input for the polar graph. And when x is equal to 0, that's when theta is equal to 0. Well, the output, the y coordinate, is 0, right? So when theta equals 0, our output, which in polar world would just be that r value, would be 0. So I would plot a point, an angle theta, right? I'm staying along this line, and it's at 0, so it's right at the pole, right? Now, when I'm at pi over 2, it would be at a maximum, right? So when I'm at pi over 2, our output would be 1. So when I sweep over, right, an angle 90 degrees, right over here, I would plot 1. And obviously on your test, you would have tick marks, and you can kind of, draw it out better, right? I'm just making approximations here. But in between 0 to pi over 2, we know that the output, the r value, is going to increase, right? So as theta increases, right, as my theta increases, so does my r value. Look at that, right? As my theta kind of increases, right? As my theta increases, that value, right, the r value also increases. So then, as you're going from pi over 2 to pi, that r value is going to decrease. So you could see it starts at 1, and it goes back down to 0. So at every point along this right here, this r value is always less than 1, right? And then it reaches 1, and then it goes back to pi, which is, or it goes back to sine pi, which is 0. And then for negative values, it actually is pretty simple. You just graph like the other way, basically, right? So for example, if I'm going to graph like at theta equals 10, whatever, like theta equals pi over 4, r equals -3 would just be going the opposite direction. So for something like from 3 pi over 2, that's -1. So when my theta is 3 pi over 2 right here, I'm just graphing in the opposite direction. That's -1. So really what actually ends up happening is all the values, because they're negative, right? You would expect it to kind of look like this, but they actually go the other way, right? Because it's all negative values. So you could see that semicircle over here just gets transformed back like that because it's negative, and then it would finish off, your circle would kind of finish off the same way. So that's r equals sine theta. Let's look at a different example. So with 3 plus 2 cosine theta, you can graph that out. So 3, and I'll talk about rules in a second, but or not rules, but just things you can memorize. But I want you to gain an understanding, right? If I were to graph this in the Cartesian world, well, my amplitude is, or my midpoint is 3 and my amplitude is 2. So I'm going from 5 to, so my max will be 5 and my min will be 3 minus 2, which is 1, right? And so at theta equals 0, right, now my output, my R value will be 5, right? Because the max is 5 and cosine starts at a max. So I can plot for theta equals 0, it's going to be a 5. And then now when I get to pi over 2, right, before, without any vertical shift, it would just lead you back to the pole. But because I'm at this, because I have this like this amplitude, or this vertical shift, it's now going to be at 3, because 3 is our midline. So I would plot 3 right here. And then for pi, right, when I get to pi, it's at the minimum, which is 1. So, and then at 3 pi over 2, it's back to the midpoint, and then it's back to 5 after one full rotation at 2 pi. So I can imagine graphing this out, I get this kind of dimple in my graph, right? Once again, it's not perfect, and if I had all the grid lines and everything, I could make this like a really beautiful shape, but I'm just making, my main point is showing you how the Cartesian converts over to the polar world. So let's try out 1 plus 3 sine theta, right? So if I were to do it like this, 1 plus 3 sine theta, my midline is now 1, and my amplitude is now 3. So I go to a max of 4, but now I go to a min of, well, 1 minus 3, which is negative 2. Right? No, that's not right. I start at 1 and I go to 3. No, that makes sense. I go to 4 to negative 2, right? So my min is negative 2, my max is 4. So at r equals 0, right, in our original sine graph, when theta was equal to 0, our r was equal to 0. But now that we have this shift up, it's going to be 1, right? The midline is not 0 anymore, it's 1. So I plot 1. At pi over 2, I'm at my max, which is 4. So you draw it like that. And then at pi, I'm back to my midline, which is like this. And now, this is really interesting. At pi, or at 3 pi over 2, I'm at negative 2. So I'm at 3 pi over 2, which is like this line right here, and then I go negative 2, right? I go the other way. So how would that look like when I connect the dots? Well, as my theta increases, so does my r. But right here, right, when I reach this midline, I'm about to hit the x-axis. And when I hit the x-axis, that's when my r is 0. That's the equivalent of passing through the pole, right? So I'm going to pass through the pole, hit this negative, and go out like that, right? So this, I think, is called a cardioid, I think. No, it's not a cardioid. These have names. I don't know the names. I think it's more important to understand the math. But the general rule of thumb is if this is A, if A represents our amplitude and B represents our vertical shift, you get this kind of dimple where you're not touching the pole when your midline is greater than the amplitude. Otherwise, you would get this kind of loop in the middle. If they were equal, in that case, you would get, if I were to just graph the Cartesian version, you would get kind of like a shape like this where it just touches the x-axis. So it would just kind of like go like this, touch the x-axis, and then kind of go back, right? So I believe that might be a cardioid. I forget the names. Let's really quickly just go over the pedals real quick. So, I could graph this r equals 4 sine 2 theta it's really just a sine graph, but now with twice, if I think about my sine terms, it's like twice the frequency. So now a period is now pi instead of 2 pi. So within 2 pi, and I usually graph to 2 pi. All right, I don't graph to 2 pi, I graph to the point where I can complete a graph, right? I can graph from 0 to pi because I know from pi to 2 pi is just a repeat. But if I were to just stay safe and just go with 2 pi for right now to see what shape I get, well, I got to kind of graph 2 of these, right? 2 of these right here. So I'll do the same thing. I start at 0, but now my maximum used to be at pi over 2. But because of this kind of, I forget the terminology, it's like a phase shrink or something. Now pi over 2 represents when it's 0, right? Because the whole thing is kind of shrunk in half. This is pi over 4, and you can solve for that, right? You set r equal to 4 because that's the maximum. You get 1 is equal to sine 2 theta, and then you solve theta equals pi over 4, and you can figure that out, right? Or you can just think about it graphically. So from 0 to pi over 2, which is right, or pi over 4, right around halfway, and then it turns back and heads back to 0 for pi over 2, right? Now, from pi over 2 to right around 3 pi over 4, it's all negative. So 3 pi over 4, I know it would be like right here, right? This is 3 pi over 4, but I'm going the other negative way. So you could see it would end up looking like this, right? Because if I were to graph it like this, right? Well, the whole thing is, all the values are negative, so I'm just it's going the other way. It's going the opposite way. So then I would get it returning back to 0, and then you could see from 3 pi, so now this is 3 pi 4 to pi, so that's one kind of full rotation. And then I'm going from pi to, now I'm going from 5 pi over 4, and 5 pi over 4 is right here, and these are all positive values, so I'm not going backwards. I'm just making that kind of loop, and I'm drawing this terribly, but these were all the tips of these petals would have a size 4. Then I'm going back to 0, and then so this is 5 pi over 4, this is 3 pi over 2, so then from 3 pi over 2 to 7 pi over 4, and remember 7 pi over 4 would be right here. I'm going the opposite way because it's negative value. Then I complete the petal. So in a perfect world, it would be a nice pretty flower with 4 petals that each have like an amplitude or like length, because that's the maximum, right? It's interesting. The shrink was by 2, and I got 4 petals. And you can continue this from after this. You would just get, your more or less petals overlapping each other. So no change in just how the graph would look. Let's take a look at this one. 3 cosine 3 theta. I'm going to predict there's going to be 6 petals because obviously, there was double the petals of the 2 here. So 2 times 2 is 4. Well, 3 times 2 has to be 6, right? So if we we could graph it. It's just, we could graph it. Let's graph it, why not? So this time it's a cosine. It's going to look more like this. So this is kind of crazy. We know that in order for r to repeat back to the same value, this in the side of here would have to be 2 pi. So theta is going to equal 2 pi over 3, right? Because 3 times 2 pi over 3, that would equal 2 pi. So this right here is 2 pi over 3. This would be 4 pi over 3. And let's just leave it like that for now. So that's 2 pi over 3. Then, well, right here would be when the inside of here is equal to pi over 2. So when is 3 theta equal to pi over 2? Well, it would be equal to theta is equal to pi over 6. So this is pi over 6 right here. And then from there, it's even increments, right? This would be, or I guess this would be pi over 3. This would be Oh boy. So that's 2 pi over 6. This would be not pi over 2. Yeah, actually it would be pi over 2. God, I hate fraction math. To an extent. So then this would be 2 pi over 3, that's 4 pi, so this would be 5 pi over 6. This would be, I think this would just be pi. If you add pi, yeah, I think this would just be pi. So this would then be 7 pi over 6. And then plus another pi over 6. I could just, yeah, so everything checks out. That was honestly kind of a waste of time. But whatever. So theta equals 0. I'm at my max. As I approach pi, as I get to pi over 6, right? So pi over 6 is kind of like this. I'm going to approach kind of 0. Okay. And then for pi over 2, well, this is pi over 3, it's all negative, right? So pi over 3 is usually like this, but then I'm going in the negative direction. So it's going to kind of flip over like this. And then I go back to pi over 2. So now I'm at pi over 2. From pi over 2 to 2 pi over 3, which is something like this, I will keep, going this way because it's all positive. And then from 2 pi over 3 to 5 pi over 6, I would go like that. And then pi, I would start going negative. Well, hey, negative in the pi direction, that's just 1 theta is equal to 0, and that connects back. If you continued forward with this, you would just loop over what you've already drawn, so there's no addition. You can just finish right here. So this is pretty cool. If the B value, I guess, is odd, you just get that many petals. Otherwise, if it's even, it's going to be double. I don't know why that took me 5 years to compute and to say. Also, plus or minuses would work, like in terms of the rules of like, oh, if the midline is greater than the amplitude, you would still get like this weird cusp without any touching the pole, regardless if it's minus or plus, right? Oh, wait. No, because if it's minus, then, because if it's minus, actually, if it's minus, then you might swap. Point is, don't memorize, just graph and you'll be able to figure it out. Okay, thank you for watching. Hopefully, this was not too long, 17 minutes, good lord. I didn't want it to take 17 minutes.